everybody to the last talk before the lunch break. I don't let Stephan keep her from lunch, but this is definitely way more important than having some food, because this is actually something that you will need in your day-to-day life, I promise you. Again, since pretty much nobody raised their hand when I asked who is signing images in the first place yesterday, this talk is for you. Now, Stephan is a very, very seasoned speaker. He's a seasoned engineer. He's also an educator. He's holding a master's and an MBA degree. He was the program coordinator at the Danube University in Krems for 2 years, for 2 master's programs. Now he's with Red Hat for more than 6 years. He's a business development manager. He's a community advocate. He's very, very active in the community scene all around OpenShift and Keycloak here in Vienna. So chances are that you've already met him. He's not an Austrian ski jumper, but I think they share the same name. And with that, I'm going to leave you with Stephan Kraft.
Yes, thanks, Daniel, for this introduction. I'm quite impressed, actually. You really were digging out almost all details from my life. So don't really need to add too much to this. Thanks for being here. Indeed, that's a topic that is sometimes a bit like, I'm always curious, I mean, presenting in front of 2 persons or maybe 200. You never know. I mean, it's like a surprise. Still, I would say it's super important, and I think really we as an industry, and here I'm really talking about the IT industry as a whole, we have to solve a problem because things are not getting better. But I promise, I know there's lunch out there. I don't want to scare you to death. I don't want to have this kind of moralizing talk about like, why are you not using that? What's wrong with you guys? But I will try to really keep it, let's say, constructive, and especially explain the technology behind this. Because at the end, I'm not really good in putting numbers there, how scary things are. They are indeed, but I'm really, I can say, passionate about the technology behind this. So who am I? Well, most of the points actually have already been summarized by Daniel very nicely. I'm not a really good skier, I can say. I'm working for Red Hat, that's also true. I have 2 kids who are quite young and keep me up at night and in the mornings. And I have to explain why I can choose whether I go to the office or not, home office. And I just had a debate today where I said, like, I have to go to school, it's really unfair. And I was like, yeah, true. Actually, in IT, we're really blessed. I mean, we can have a lot of freedom. I can work sometimes in the evenings, in the nights. Well, school is always starting at 8 o'clock. That's how it is. Bad luck guy. So let me start with a very important question. Who thinks that security is important? Just raise your hand, please. Okay, good. I can continue. Who thinks that security is easy and fun? Okay, at least 1, 2, 3. Yes, I'm counting you. Great. Well, actually, I admit they're stupid questions somehow. But I think that people are not stupid. And I think, and that's what I already said in the beginning, if security is not applied, if security is not used, if something is not done in a secure way, then maybe there's something wrong, not with the people, maybe as well, but maybe also with the process. And I found this statement, which I found really interesting, to say, let's view security as a user experience problem. So if something is not working, if something is not adopted, if something is not applied, then maybe there's something wrong with the user experience. And I mean, come on, everybody of us has seen this, maybe internally, externally, that something is slowing you down with security, something is blocking you, you want to code something, you want to do something, and then somebody else, usually older than you or smarter than you, saying you cannot do this because of security. So this is not really new. I always like to take examples where things have actually worked very well. And I guess everybody knows SSL. It was even mentioned by you yesterday, 1995, Netscape has invented SSL. So we're talking about a technology that is around for 30 years. So the technology was there. I've learned yesterday also there was even a bank, an online bank 1 year before. So I mean, well, banks tend to be secure, or should be secure at least. So the technology is there. The question is, was it really applied? So if you look at these statistics here, this is in fact only from 2014. Unfortunately, I didn't find any numbers from before. But just from 2014, only 50% of all the web pages worldwide were somehow secured, were using TLS, HTTPS. So this is not too much. But then actually the curve was going up, and now we're somewhere at 96%, which is quite okay. So what do you think, or any ideas? What was the big game changer there? Yes. Did everybody hear this? Let's encrypt, indeed. So Let's Encrypt was, in fact, issuing certificates. And as you can see here, the numbers, they quite correspond to the previous statistics quite nicely. So in fact, it's really steeply going up. And they have done certain things very nice or right. So first, it was community-driven. It was not one big tech company charging a lot of money, but it was really from the community. It was even free. And maybe most importantly, it was fully automated. So maybe you know the ACME protocol, where basically you just prove that you're in control of a certain DNS domain, and then you get automatically a certificate. So it's easy, it's kind of easy to embed in processes and so on. You can even rotate it automatically. Great. And that's the reason why people suddenly said, okay, let's use this. But unfortunately, this is not the only problem that we have in IT. Well, we have many, many problems, I guess. But now a specific problem is really about cybersecurity. And I mean, you don't need to read tech blogs anymore. You can see it everywhere, right? Cybersecurity threats. We had the NPM problems there. We had on the airports problems and so on. So this is actually not getting better. And this is the only slide, I promise, where I'll scare you a bit. It's going up. And in fact, if you're looking around in the world, it's not really a nice place at the moment sometimes. The community here is great and nice, but outside, unfortunately, there are people that are evil, have certain interests, doing espionage, or just sometimes it's a business model. So hacking as a business model becomes also more and more popular, where basically you can just, request a ransomware attack and you pay a bit and you get this back. So this is here, and we have to deal with that. So the question, and this is only part of the cybersecurity problem, obviously, but one of the questions, if you talk about supply chain security, so how to secure your supply chain, is really about, as easy as that, how to distinguish between the good and the bad guys. Or let's maybe put it a bit more correct, the guys with the good intentions and the guys with the bad intentions, because even good guys can write bad code. So this is actually what you want to achieve, and in fact, again, there's a solution for this, which is cryptography. And this is also not something very new. This is around for some time. We have PGP, we have GBG, we have the different kind of asymmetric keys and so on, private-public key. We know all that, right? And in fact, cryptographic signing can achieve mainly two things. First, it provides provenance. So in fact, you can, if something is signed, you can really say it's coming from this person. I put it on the quotes. I will come to this point later on. And you can say when this was signed, usually with a timestamp. The second thing, you can also kind of verify the integrity of the document that you have signed. That means if someone later on would add something, the signature would not match anymore, and this could be easily detected. So that's great. But it's challenging. So who ever has created a key and well, then you get prompted for a password. What is the password again? Oh shit, so I have to basically create a new key and so on. As well, where to put the private keys. I mean, okay, do you have HSMs and so on? You can, but usually, or very often, it's just put on your local machine or somewhere maybe forgotten. Yeah, what happens if the machine is broken? The second thing, and I put it under quote before, in fact, if you do a verification with the public key, then basically you just know that, yes, this public key corresponds to a private key. But is it really actually from this person that you want to have it from this person? Just imagine if you have like a repository, and maybe this is called typo squatting or combo squatting. Somebody just basically clones the repository, and in fact just puts maybe a slightly different name, keeps everything the same and so on, and then puts his kind of, I'm the attacker, public key there. So yes, if you do the verification, it would work, because it's, again, just matching with the public key. But who is actually the identity behind? You don't know this really. And of course, the problem is always about distributing the public keys and also later on for revocation. So how do you, basically, if you have the suspicion that maybe you have been hacked, how do you revoke this and so on? We have this nice little concept about revocation lists, which we all love. And by the way, somebody told me it would be a good idea to rotate the keys and not keep them forever. Everybody is doing that, I know this. So it's challenging. And coming back to the previous thing or previous statement I was giving, it seems we have again a user experience problem. Because Daniel was asking who is signing container images. And well, I can repeat the question. I guess there will be not too many hands up. And actually, by the way, signing is not helping anything, because if you just sign it, the question is who is verifying these container images. And what about other software artifacts? What about vulnerability reports, SBOMs? If you think about Git commits, they're also software artifacts that are important and should not be tampered with. So actually, it seems we have something like a user experience problem here. And that's exactly where Sigstore come into play. Who has ever come across Sigstore? Okay, a few. Who has ever worked and used Sigstore? Okay, great. So Sigstore was invented 2021, so it's like 4 years ago, with some companies that you can see here, like Google, JaneGuard, Red Hat, and also universities from New York. And in fact, it's a very simple project. So let me check this. It's in fact under the Linux Foundation or the OpenSSF. And the goal is very simple, just simplify the signing and verification of software artifacts, mainly in the supply chain security area. The good thing, also this company together, so I think it's mainly Google and Red Hat, not sure whether there are other SREs as well, also maintaining kind of a service, so a public good instance of Sigstore. So we'll see later on the components, but the good thing is it's not just kind of specification, some tools or utilities, but it's really, you have basically the whole back end also available, which you can use. And coming back to the user experience thing, you have really tooling that abstracts away, let's say, the complexities of the components below, which is cosign, git sign for signing and verification, signing and verifying images. So in a nutshell, and I like this because it helps, I think, to make this kind of comparisons. It's a bit like the Let's Encrypt for supply chain security. Let's now compare, if we talk about Let's Encrypt, we've talked about Let's Encrypt already quite a while. So what are kind of the similarities and what are the differences? So both of them are in fact an automatic certificate authority, and both of them are free, which is good news. Of course, let's say the domain is different. Let's Encrypt is for TLS web server authentication, while Fulcio is, and by the way, I have to explain this, under Sigstore, you have several sub-components or sub-projects. And one of them is Fulcio, which is in fact a certificate authority under Sigstore. So Fulcio is in fact used for software artifact signing. So it's issuing certificates that are used for software artifact signing. The great thing here, we'll mention it later, but maybe because we're already talking about it, they're really ephemeral. That means they're short-lived. In fact, usually for 10 minutes, and only for this one event of signing a particular software artifact, and then basically at least the private key is thrown away. The subject, of course, is different. Let's Encrypt is dealing with DNS domains, while for Fulcio, it's people or workload identities. So I already mentioned this. The validation process is done by the ACME protocol. What do you think would work nicely for people? What kind of standards do we have already for authenticating people? Any idea? OIDC, OpenID Connect, exactly. So fortunately, they're not reinventing the wheel, but basically they're using what is already there and established, which is in fact OpenID Connect. So now going a bit into more details, what really is included in Sigstore. So the first kind of protagonist is in fact not even part of Sigstore, but is very important for Sigstore, which is the OpenID Connect provider. The OpenID Connect provider like Keycloak, of course I have to mention Keycloak as the kind of founder of the Keycloak group, but in fact it would work with other OpenID Connect provider, of course, as well. What in fact the OpenID provider is doing or saying is in fact, yes, you have authenticated hopefully successfully with me, I know you. Of course here you can apply things like multi-factor authentication, so not only username, password, but maybe biometric, whatsoever. And kind of the testament that I know you and that you have successfully authenticated, because here you get a JWT, a Java, JSON web, Java web token. Thank you. Okay. Which is in fact an identity token just signed by the OpenID Connect provider, that in fact this has been successfully authenticated. Now the second part, or the second protagonist, is the FULSI. Already mentioned this. It's a certificate authority, and the certificate authority in that case takes as an input, in fact, a JWT token, so the authentication is kind of delegated, and also gets a public key. And again, with cryptography, it's ensured that this public key is in fact, or the person who has sent this request is in possession of the private key, of the corresponding private key. And what basically the result out of this verification is an X509 certificate, yeah, with the subject of the OpenID Connect identity. The third part is kind of the, if you want, the blockchain, the transparency ledger. So it's an append-only ledger, meaning that you cannot basically after the fact change something, you cannot delete something. It's really for audit purposes. And in fact, what is kind of included here as an information is that at a certain point in time, this particular software artifact was indeed signed by this particular public key certificator with this identity. If you take all this together, then you get exactly this information. So these three guys together kind of testify that a certain software artifact, usually you do it via hashes, has been signed by an identity at a certain time. And that's exactly what comes back to what we want to achieve. We want to really understand at a certain point, a certain person, for example, Linus Torvald or somebody who is known, has really signed something, and this artifact hasn't been changed since then, so I can trust it. So just in a nutshell, and then I come to the demo, what are the key advantages of Sigstore over maybe existing or other approaches? I already mentioned it, all the certificates are short-lived, ephemeral. So that's the reason why sometimes it's called keyless. In fact, it's wrong because there's still keys around, but you would not see it. You wouldn't even see it as a signer, and you would also not see it as a verifier. The second thing, the private key never hits the disk. That means it's always in memory. It's just there once to sign the JWT token, and especially to sign also the software artifact. Yeah? Afterwards, it's basically thrown away, and just the public keys then in this Raycore log or in a Sigstore bundle for verification later on. So the cool thing, if you think about this, the key is only valid, or the certificate is only valid for 10 minutes, but the verification can happen maybe 2 months later, 1 year later. Doesn't matter. So the key at this point in time, or certificate at this point in time, would not be valid anymore, but of course for verification it's still possible. The third, and that's maybe the most important one, the verification is not done against the public key, but against an identity. You will see it later on in the demo. Well, user experience, signing and verification, it can really be done in one command. So it's a cosign sign and a cosign verify. And in fact, with some environment variables, you can achieve this. And you have, if you want, the transparency log to really keep track of all the events, and you would be able to spot also suspicious activity. For example, if somebody is requesting a certificate under your email, you can just with a monitor check and see that something obviously is happening there. So now we get to the demo, which is hopefully working. I have to put on my glasses. I'm not getting younger. So this is what I want to show you, and hopefully at lunch I can then relax because everything has worked. So first, I will do the classical kind of scenario with container image signing. and verification. I'm always using the public instance of Sigstore. So in fact, I have it on my machine as well with a private Sigstore, so you can deploy it on your own Kubernetes cluster or OpenShift cluster. But in that case, I'm just using the public Sigstore because for the demo, it's good enough. Then I will show just the attestation, so we'll just add some SBOM to the container image, and then hope we can verify it successfully. The second thing, the second block, if we still have time, is then do the same for Git commit signing. Because Git commit as such is again also a payload, it's also an object, and you should also sign it that not somebody can maybe later on change it. I mean, with Git commit minus amend, you could basically just change the owner or the comment. You don't want this, you want to have it signed and ensure the integrity. And then we could just go through this because I found this quite interesting, how easy it is actually to just fake, if you don't sign it, how easy it is actually to fake credentials, because it's self-declaration. You can put yourself as Linus Torvald, Mickey Mouse, whoever, yeah? And of course, this is not what we want. Good, let's cross fingers. I go now to the terminal. So in fact, what I've prepared is here just an image. I've uploaded it to Quay, as you can see here. It just has a tag 1.0. I hope it's big enough. And, well, nothing more there. So let's just naively try it out and say cosine sign. And I'm using the environment variable image. Is it broken up over there? Should I go a bit down? Okay. So what is he doing now? First of all, okay, he's accepting that I want to sign this and asking me, okay, is this really my data that I'm putting potentially to this record log? And now he's doing a redirect to this page. So in fact, we are basically using the backend from Sigstore, which is just an instance maintained by Google and Red Hat and others. And in fact, just by definition, by design, you have 3 different options now how you can authenticate yourself, either GitHub, Google, or Microsoft. Unfortunately, with the public good instance, you cannot add your own OpenID Connect provider there, which could be one of the reasons why you want to use your own private one or manage your own private one. So in that case, I'm just using GitHub. So I'm clicking here. Let's go back to the command line. Now he's also nicely telling me that, in fact, by the way, the repository is private. Are you really, really, really sure? Of course I am. I always know what I'm doing. And now he's pushing the signature also to this repository. So the question might come up, okay, where is actually the signature now? Well, use the container images. It's a bit like a trick that the container image itself is then wrapped in an OCI image and also uploaded to the same repository, which is nice because I don't need to kind of have my own portal where I put the signature and the public key and so on, but I can just have it side by side in my container registry. So I could even, if I do a Scopio inspect, if I go up here, I would see now I in fact have 2 tags. One is 1.0 and one is this hash over there with the extension SIG. Yeah. Funny enough, in Quay, I don't see this really because it says, okay, you are having a signature. I guess you don't want to have this displayed, but he shows this nice little icon here. Yeah? So this means now that this container image is signed. Well, that's it. And let's now do the same thing from the other side. Let's do the verification. Again, it's one very simple command. I say verify image. Oh, error, that's not good. Well, yes it is, because he tells me it's nice that you want to verify, I can verify against the signature, but actually against what identity do you want to verify? And so I have to add now the identity, which is me, because that's how I'm kind of authenticated via GitHub. If I do the same thing again, he tells me, okay, nice that you're giving me my email address, but what is actually the identity, the OpenID identity provider that is kind of managing this? And now I'm doing a copy-paste already here. I will show it later on. Okay. Okay, let's do this again because I've forgotten. What's the OpenID Connect provider? Maybe I have some in the slides. So, should be this one. And now what he does is, in fact, he goes back to Raycore and validates several things, so which are displayed here. So first of all the claims have been satisfied. That means the certificate is not being used by anything else. I mean, it's really the scope is kind of signing. Then he's checking that there is indeed an entry in the transparency log. We will have a look at this in a second. And that all kind of the hashing and so on was trusted, the signature really matches to the actual payload. So I already mentioned there is this Raycore log. Let's have a look there as well. He is kindly already giving me the ID here. I copy this. And there's also a nice GUI that is basically just giving an easy way to query the transparency log, the public query, public transparency log. I could do the same via CLI or REST API, but of course here for the demo it's nicer to do it like this. I'm just choosing here the log index and do a search. And that's exactly now the entry in the public good instance. So if you want, you can just check exactly this URL email address. Exactly this URL. You should find exactly the same thing. And this is in fact showing me some information. So first of all, this entry is of type hashed record because the payload has been hashed. I've created it 4 minutes ago, indeed. That was when I was doing the signing. And this is the hash of the payload. This is the signature, base 64 encoded, but that's how it would do the verification. And this is now the public key certificate. So some things interesting to note. I told you already, the certificate is only valid for 10 minutes. So it was created 4 minutes ago and is only valid for 6 more minutes. While this is just technical information, what kind of algorithm has been used. This is the claim. So this is only to be used for digital signature. I could not use the certificate for TLS or anything else. And this is the subject alternative name that has been taken out from the OpenID Connect JOT token, in fact. So this is my email address, and this is the OpenID issuer. So that's how it works. That's in fact the thing. Let me quickly go to what's happening behind the scene, just to explain a bit better. In fact, I've just used one command, cosine sign, but what is happening in fact behind the scene? I'm kind of the role of the developer. And if I say cosine sign, in fact, this flow starts. I request a certificate. He's checking for the OpenID Connect provider, whether maybe a session already exists, or if not, then he would then show me basically the login screen, like username, password, or if it's configured, some additional multi-factor authentication and so on. If this goes fine, the next step is in fact that you send the request, the certificate signing request to Fulzio together with the JOT token and the public key. If Fulzio is fine with that, he would then kind of publish this to the transparency log, basically keeping track of this, exactly what you have seen before. And if everything is fine and also the transparency log kind of reports back, yes, I've received this and I will include it, only then basically Fulzio will send back this signing certificate, and then you can basically sign whatever you want. In that case, it was the container image. Not the whole container image, in fact, it was just the meta file. So this is how the flow works, and everything is done under the hood with cosine sign. Yeah? On the other side, if you take the kind of verification, it starts here. The end user basically looks up the artifact, wants to verify this, downloads, in fact, the signature, then with the signature goes to the transparency log and say, do you have an entry with exactly the signature? Raycore hopefully reports back, yes, I do have one, which I've shown before. And then basically all this verification is happening. And then you can ensure or be sure that this is really coming from this provenance. How we're doing on time? Still, okay, great. All right, this would be in fact the first use case. If you're interested, because it's really a nice example also for incorporating this security into the actual original flow, I would like to show the git commit. So git commit at the end also just creates a git object, a git commit object, and this we can or we should also sign as well. Fortunately, I'm already in a git repo. Let's see that this is in fact not really very much populated, but it's okay. And I would just create, let's say, because we are the cloud native days, cnd text file. So add it to the git repo. Looks good. Okay. And what I do now is in fact show different scenarios. Yeah. If you look at the config file, it's almost empty. This is just basically how you configure your git commit. Well, this is you basically have a link or a pointer to the public one. This is some information about basic information about the core, and that's it. So nothing about who I am, nothing about how to sign whatsoever. So this is in fact our starting point. And let's maybe just add some string to the file. This was it. Just to be fast, do immediately a commit. I call it blank commit. And a git push. So, what he's kindly telling me now, in fact, well, since you didn't provide or self-declare anything about yourself, no name, no email address whatsoever, I've just taken the user ID from your machine and basically the domain or the host name from your machine. So you can change this in the future, but that's how it is. Yeah. So if you look at the git repo, let's do a refresh. We have now here our file. If you look at the history, you see it's a blank commit, and it doesn't really know, well, it's a Stephan Kraft, but there's no matching with an email address whatsoever. So let's take the next step and say, okay, let's self-declare who we are. I've just written a nice script for this. Super proud that I'm writing scripts. And this has just added this awesome information about myself and the email address skraft.reddit.com. So, well, that's good. So let's do exactly the same thing, add some string, and maybe do another git commit and call it this time commit with self-declared credentials. And then do a push. Yep, looks good. Let's go back to the git repo. And you see that there should be another item now, commit with self-declared credentials. And here's mapped me now successfully, so you see the photo to the owner of the repo. But now let's be a bit brave and maybe even a bit like enemy-like. How easy it is actually to just change the settings? Well, I guess it's very easy. I just put here under my name, what do you want to put there? Some hacker guy or some famous guy? What? Papa Schlumpf. Okay, that's a good one. I like this. I was more expecting like Linus Torvald or something, or Kent Beck, but yeah, why not? Yeah. So what's the email address of Papa Schlumpf? You know this, or let's say Papa. Okay, I take this one. Good. So I just save it, and let's now do another commit. Let's just that we can easily identify with faked credentials. What do you think will happen? Did already. So. No. Here we go. Just trying. Yes. So Papa Schlumpf was now successfully creating a commit. And that's it, yeah? So in fact, of course, you could put anywhere there. I mean, Papa Schlumpf would be obviously that this is not a great developer, but maybe if you put something known person, then it would be there. So that's not ideal, and that's exactly how sometimes, you know, these hacking attacks can happen. So what I have to do? Well, I can sign it. And this is, again, quite easy. I just have to call this script here, and I will show you later on what's the effect of it. Let's go to git config. In fact, it has just added 3 items here. So first of all, I'm telling, from now on, each time when I do a commit, please sign it. Don't get confused because here it says GPG sign. This is just legacy because in the beginning it was always GPG. It's not really GPG at this point. Then I tell him, use the program utility git sign. So git sign is just utility, command line utility that I've installed here locally. So what he would do is if it starts the commit process, then he would basically just redirect to this git sign and gets back the answer from git sign. Yeah? We won't really see this actually if we do it, but git sign will be called in the background. And then the last thing is the format I can specify would be x509. That's it. Let's see what happens if we do exactly the same thing here. Let's change just maybe the comment to signed commit. So he's again doing a redirection the same way as before you have done with the container image. This screen already looks familiar. And he has now again created an index in the transparency log. We can look it up if you want. And if you look at the, because this might be interesting, at the commit file, he has now included in the commit file this signature. Yeah? But let's maybe look it up in the record. The transparency log, where was the, here we go. This was the ID. So if we go back here, so you see it has happened a few seconds ago. And this is again just a certificate, only the certificate for signing this git commit. So each time when I do a git commit, you would create another certificate, again only valid for 10 minutes. You see here again the same like email and OpenID issuer. You see the scope and so on. So that's how it is. The last thing before I stop, just coming to the same, how would I verify this? And this is in fact very similar. I just say git sign verify. And he would again ask me, well, you need to specify the certificate identity, which is me, and the certificate OIDC issuer, which would be again GitHub. And then again, you get back, yes, there is indeed an entry in the transparency log. I've validated the git signature, I've validated the record entry, and I validated also the claims. That's what we want to achieve. So just summarizing, hopefully what we have seen and I could convey. Supply chain threats are on the rise, that's for sure. There are regulations out there. There are indeed many, many initiatives going on how to secure this. I don't want to kind of claim that this is solving everything. Obviously not. Yeah? And signature and verification is just helping with the provenance problem. It doesn't guarantee vulnerable free code and so on and so on. It doesn't ensure, for example, encryption. Yeah? Signature is not encryption. That's something else. But it really helps on this provenance problem. So signing software is one of the key ingredients. Conventional signing with long-lived keys is cumbersome and risky because then you have usually these certificates that are around for some time. You have to include them in maybe your CI/CD pipeline. Maybe you forget about them, that just linger around and so on. And that's a great attacks or attack vectors for hackers. Sigstore is, as I said, open source project available since 2021. It's stable, it's secure. Red Hat, by the way, is using it as well for our software development. And if you want to use your own OpenID Connect, or you don't want to see basically your data, your email address and your OpenID Connect thing in the public Sigstore, then of course you need to host and manage your own Sigstore instance. And Red Hat indeed also has a product for this, which is called Red Hat Trusted Artifact Signer. That's it for the moment. I'm really relieved that the demo was worked out. And maybe we can just spend the last minutes for questions. Thank you.
Okay, so 2 questions actually. First, how would you do this in a CI pipeline? Because nobody has time or the want to sign images manually.
Yeah.
And how would you do this with Podman? You've shown us Docker and Scopio, and you want Podman pull to do the verifying. No manual having to know how cosign works or whatever you use, just Podman pull enforce.
Okay, so first question is how do you integrate this in the CI/CD pipeline? Well, you would use exactly this kind of tooling in a CI/CD pipeline as tasks, or if you use Jenkins, it would be that just as steps. Yeah, you usually do the signing in the beginning. Very often, what is advised is that you don't have both steps in the same pipeline. So you would maybe do it, especially for your own self-development. You would sign the software maybe in one pipeline, and then maybe have a deployment pipeline where you verify it. Yeah, because otherwise it's a bit awkward to sign and then verify in the same kind of environment. But that's how you can do it. Usually it's you just use cosign for this. Does this answer your question, first one? Okay, then please let me know.
The issue here isn't that you can sign it in a pipeline, but which credentials would you use? You'd have to have a machine account.
Yeah, usually you would use service accounts, yeah. So usually you use service accounts. I mean, there is another cool solution, actually, by Spiffy, where you basically can use workload identities, because that's what you want to do. Also for the service accounts, ideally you don't have kind of username, password. But this is another story. But usually the standard case would be service accounts, yeah.
Okay, thanks.
The second question was about, please help me.
How can you, on a developer's machine, enforce this?
There I have to admit, that's a shame for Red Hat. I mean, I've played around with Podman, but not really trying this use case. But I know that Podman uses or has some integration with this, so at least, maybe not for Sigstore, but how to basically automatically, when you kind of pull an image, that you verify also its provenance. But a good point to remind me that I have to try this out. Thanks. Other questions?
Yeah, just a comment. I think another thing that really happened with the whole HTTPS and Let's Encrypt and so on is that the browsers started showing a red.
Yeah.
Yeah. So that's another step I would say in the user experience here, that users become more aware and the tooling lets the user know maybe you shouldn't trust this package or container image because it wasn't signed.
Yeah, absolutely right. I mean, that's what I said a bit. If you do the kind of signing without any verification, and this is kind of the verification and alerting, by the way, this is not signed, please do something. Yeah? And in fact, if you do it like with the Podman, then ideally also you have this kind of alert, by the way, you're pulling an image that hasn't been signed or where you don't know the provenance.
Thanks. Can you maybe quickly go over the config of cosign? How you configured that it uses Sigstore?
Yes. Well, in fact, what you usually do, I mean, in that case, it's very simple because I'm using all the defaults. But if you, for example, would point to a private Sigstore, then you would need to use something which is called the update framework, TUF. And this basically then downloads all the public keys and ensures that you're really talking to the right Fulcio, to the right record, to the right, there's a timestamp authority, and so on and so on. But that's usually what you would do upfront. Okay. There was another question over there? If we still have time.
Thanks, great talk, by the way. What I wanted to know is how, or is there a way that you can basically, for the code signing, that the commit is signed, it kind of automatically check that it is signed, and you get kind of an alert if it's not. Like for example, you have in your own repo you had your own signed commit, and then another one that wasn't signed at all, but with still your name. So is there any kind of check mark on there or any way to automatically see that?
Yeah. So it depends, of course, on the Git repository that you're using. I was using GitHub. And I think also for GitLab it's the same. You can define so-called branch protection rules or something. So basically it would not allow any a Git commit that is not signed on this particular branch. So you could even say, for example, on certain branches it's okay to not have signed it, but on others it's not okay. Yeah. So that's how you could enforce it. Microphone's not working?
Not working.
Oh.
Okay, now it is. Okay, so and then GitHub or whatever can verify that the signature is okay and that it's actually yours, because I mean, it could be any signed commit.
That's true. Maybe I still have it somewhere here. In fact, if you would now go to the GUI, it would show it as unverified. So it would say, GitHub would say, okay, yes, I see that you have signed it, but I cannot really check it because I don't trust the Sigstore CA.
Okay.
Unfortunately, at the moment, for GitHub at least, there's no integration with Sigstore. I think it will come because, yeah, you cannot really configure it. I just was checking it yesterday. It's not supported as far as I know. Maybe you tell me something different. But usually, ideally, in your Git repo, you would establish once a trust relationship between your Git repo and the CA of Sigstore, and then it should work. Then even it should check that, yes, it has been verified.
Okay, thanks.